Here we assume that the some parameters of the bending moment applied on the bracket frame of cantilever beam. Given P equal to 25 kilonewton, allowable shear stress 80 Newton per millimeter square, eccentricity is 100 millimeter where the load P is applied from the bracket, and this is the cantilever beam, and D is the thick distance between the two fillet weld. G is the center of gravity. Y1 is the D by 2, which value is 50 millimeter, and weld bead length B 50 millimeter. Find out the thickness T and throat thickness T and leg of the weld H. First, applying the IXX, applying the parallel axis theorem, and ultimate the result is T into BD square by 2. We apply the value of T into 50 into 100 whole square divided 2. Then we got 250,000 into T millimeter per power 4. Now the bending moment equal to P into E, which is force into perpendicular distance. Therefore 25 into 10 to the cube into 100, this is 25 into 10 to the 5 Newton millimeter. Now we got the primary shear stress applying the formula tau equal to P by A, where area equal to 100T and P equal to 25 into 10 to the cube divide 100T, is equal to 50 divided T Newton per millimeter square. This is the stress. Now finding the bending stress, sigma B equal to m by sigma by equation. Then we put 25 into 10 to the 5 bending moment into 50 y into 250,000 T IXX. Then ultimate the result is 500 divided T Newton per millimeter square. This is the bending stress. Now maximum shear stress theory, tau equal to sigma B by 2 root under sigma B by 2 whole square plus tau 1 whole square. Then we put the value of the sigma B 500 root under 500 divided 2T whole square plus 250 by T whole square. Then we get result of the sigma B and tau 1. This is the tau, get the value is 353.6 divided T Newton per millimeter square. Now the find out the T, then tau level formula is applicable. Then tau level equal to 353.6 T, which is Newton per millimeter square. Therefore the throat thickness T equal to 353.6 divided tau level. Then putting the value as the tau level is 353.6 divided 80 equal to 4.42 millimeter. We got the throat thickness of the weld. Then weld leg dimension, which is H, we can find out by the applying the formula H equal to T divided 0.707. Then 4.42 divide 0.707 equal to 6.25. Then we round off the dimension. Then we get the 7 millimeter length of the H value, which is the leg length. Thank you.